All right, so what do you think about this?
Well, I'm thinking about A. It should be the range should be has to do with something with -4 because it's in vertex form.
That is in vertex form. What would the vertex be?
It would be 2, 4
Exactly. So if I just were to give you a quick sketch, it opens up. How do I know it opens up?
because there's no negative sign in front of well,
Exactly.
not yeah,
You
outside.
know,
Yeah,
in front of that A term, in front of this guy, right?
yeah.
All right. So it opens up, and this is the lowest possible point. Agreed?
hmm
All right. Now, I want to make sure we're clear about this. What does this mean?
That's a restriction, right?
Well, it's a domain, but you're right. It's a restriction on the domain. What are the only x's we're allowed to use?
They have to be greater than or equal to 2.
But what's important for us to know is that it could be 2. Does that make sense?
Yeah.
But because we're only using the x's that are above 2, what happens is I actually am only going to get this part of the quadratic, right?
hmm
All right, so now, how can we state the range? What does it mean to be the range?
It's your y values.
It's the y values. What's the smallest possible y value?
4,
So we could say, and use the interval notation and say 4. Now, what's the biggest possible y value?
infinity. It can be anything.
We could do that. Or we could also just say y is greater than or equal to 4. They both pretty much mean the same thing.
Yeah.
All right. So yeah, I totally agree with that. I like your thinking too. So now what does B mean?
That's all real numbers.
No, right here. What are they asking us to do?
Oh, it means to find the inverse.
Exactly. So what do you remember about finding the inverse?
It's when the x and y switch.
Yeah, so let's just do that. Now, while I'm writing this, I want to make sure that we make a note. I'm going to switch these. X equals y minus 2 squared minus 4. Okay, so number one, if you ever have to find the inverse of a quadratic trinomial, it needs to be in vertex form. So, for example, had this looked like this, x squared minus 4x plus 4, and then, whatever, had it looked like something like this,
hmm
we would have had to put it in vertex form before we tried to find the inverse of it. However, they were nice enough to give it to us in vertex form. So, take a minute and work this out. Tell me what you get.
Yeah, I got the same thing.
So then, how would you finish it?
You add 2.
So it's going to be f negative 1 of x is equal to 2 plus or minus the square root of x plus 4. Now, there's a problem. We didn't use the whole quadratic, did we?
No.
However, we just found the inverse of the whole quadratic. So here's what we got to keep in mind. You know this plus or minus square root thing?
Yeah, I was gonna ask you about that.
All right. Whenever you take the square root of both sides, you should technically make it plus or minus. Okay?
Mm-hmm.
Now, because we only used this half of the quadratic, whenever we're using the x's that are above the vertex, then this square root is always going to be plus. If this had been different, and then it would have said x is less than or equal to 2, which means we would have been using this side over here, then when we took the square root, it would have been negative square root of x plus 4. Does that make sense?
Yeah.
So, because what's happening is that if I graph this, if I were to go and graph it, it's going to look like this. One half is going to look like this, and the other half is going to look like that. The problem is that that's not a function. It doesn't pass the vertical line test. However, if all I have is half of it, well, half of it does pass the vertical line test. And so the reason they've limited this domain is so when we take the inverse of it, that it still can be a function. So in this case, what's going to happen is that I'm going to take this minus sign off, and it's going to look like that.
All right. So when the x is above the vertex, that's when it can be positive, and when it's below, it's negative.
So exactly, and it doesn't make a difference if it's open up or if it's open down. If you know the quadratic had been like this, if we were using the x's that are above the vertex, then when you square root it, it's going to be positive. And if we would have used the x's that are below the vertex, then we would have used the negative when we took the square root. Okay?
Yeah.
All right, so now what does C say?
It says, given that a equals negative 5/3, solve the equation f of x equals g of x.
All right, so basically what they're saying is replace that a with this negative 5/3. All right, so let's just do that. And it seems kind of weird that they put an a in there and then they tell you immediately what they want you to be. But, I mean, later on they aren't going to have that number. Right now we do. So let's say, what am I going to write? G of x is equal to what?
Negative 5/3 x plus 2.
Because literally all I'm doing is putting that in there. Does that make sense?
Yeah.
Now what do they want me to do?
They want you to make it equal to f of x.
So what does g of x equal?
G of x equals negative 5
over the x plus 2. Yes?
Mm-hmm.
And what does g of x equal? Oh, I'm sorry, f of x equal?
X minus 2 squared minus 4.
So we're just going to make them equal. Now, and now we want to solve it. So how would you go about solving it?
Well, the first thing I'll do is, I think I would expand the quadratic.
Yeah, I love that idea. So, yeah, because I'm going to tell you, when you're solving, I mean, sometimes you'll notice how we square rooted both sides, but when you're solving and you're trying to solve, try to avoid square rooting both sides if you can help it. So in this case, by expanding this, so I'm just going to rewrite this now. Negative 5 over 3 x plus 2. So then what happens when I square that binomial? What am I going to get? What's x times x?
X squared.
And then what's negative 2 times x?
Negative.
Well,
That's negative
and then I'm going
2x.
to double it, right? So it's going to be negative
4x.
Good. And then what? Plus 4?
Yep.
And then minus 4, right?
Mm-hmm.
All right, well, you'll notice now the minus 4 and the plus 4 clearly cancel each other out, right?
Yeah.
So now what am I going to write?
You can get all of the numbers to one side, so you add plus 5/3 x and then subtract by 2.
All right, so help me out. What's negative 4x plus, and this is going to be what, 1 2/3?
I believe so.
Just use your calculator. What's negative 4x plus 5/3? Or what's negative 4 plus 5/3?
That's negative 7/3.
And see, don't even give it, don't, just let the calculator do the work. All right? And it's
All
going to be
right.
x, right?
Yeah.
And then what am I going to do with this 2?
We subtract it by 2,
So
which
it's
gives you.
minus 2
Yeah.
equals 0, right?
Mm-hmm.
All right, now we're going to solve it. So how are we going to solve it?
Quadratic formula.
All right, so you could definitely do that. If you made the quadratic formula, make sure that you write it down. It's going to be what? 7/3 plus or minus square root 7/3 squared minus 4 times a times c, which is negative 2, all divided by 2a, which is 2, right? And then
Yeah.
what are you going to do?
You're going to put it in the calculator.
You're going to pick up your calculator and plug it in. So go to menu A and tell me what happens when you put this thing in.
I got 3 and negative 2/3.
So you're going to get 3 and negative 2. Now notice what I'm doing down here. If I multiplied everything times 3, I would get 3x squared minus 7x minus 6. And then I could factor this. Now don't get me wrong. I'm not saying there's anything wrong with what you did, because clearly it's faster, because you see what I'm doing here. But I'm going to get the same thing. I'm going to get that x is equal to 3, and x is equal to what? Negative 2/3?
Yeah.
All right, now, here's what we have to be careful with. Here we are on part C, but tell me about the domain.
It's greater than or equal to 2.
So, and keep in mind, clearly what it says is x has to be greater than or equal to 2, yes?
Mm-hmm.
So can that be one of our answers?
No.
Nope. Because we're not allowed to use x is less or negative 2/3, are we?
No.
So what's going to happen is we're going to get 2 answers, but only one of them is going to be good. Does that make sense?
Yeah.
All right. So now what is C? That's C, right?
Yeah,
No,
let's see.
that's C. Yeah, I labeled it B. All right. What's D say?
So it says given set of that GGF, the inverse 12 equals 62, find the possible values of A.
All right. So let's talk about that. What does that mean?
You're gonna find a composite function, and then you're gonna do the inverse, I think.
All right. Now there's 3 pieces here. Essentially, what are we going to do?
You're going to put you're gonna put f to the x values of g, or that
Into G.
Yeah.
And then we're going to put that back into G. Now, what I'm going to tell you is it gets a little dicey when you start doing 3 of these things. And also with a number, if I've got a number, basically what this means is I'm going to put a 12 into the inverse. And then what's going to happen is I'm going to get an output. And then the output is going to go into G. And then I'm going to get another output, and that's going to be G. And that should equal 62. Does that make sense?
Wait, so we put the inverse of f to g, and then we do it again, and then that's when we put in 12?
So basically what I'm suggesting is we break this into parts. I agree, this is going to go into G, and then that's going to go back into G again. But let's start by finding out what f negative 1 of 12 is.
All right.
If I put a 12 in there, into the inverse, what's going to come out? And remember, our inverse was what? This here? So, is equal to 2 plus square root of x plus 4, yeah?
Mm-hmm.
So, if we put a 12 in there, what's 12 plus 4?
16.
What's the square root of 16?
4.
And then
Or
what's 4 plus 2?
6.
So, if I put in that, a 6 is going to come out. Okay?
Mm-hmm.
All right, now let's do the GG part. Okay?
Mm-hmm.
So basically what that means is what am I going to do?
You're gonna put that. You're gonna put f into g or to x
I'm going
to
to put
x.
G into G, right?
Yeah.
So what's that going to look like? First, what do I write?
You'll write down ax plus
Okay.
2.
Well, what I'm going to write is A. Now, what am I going to replace the X with?
Um, you're gonna replace it with f, right?
See, now, nothing to do with F. Notice there's only G's here.
Okay. Oh, then
So
it'll be
I'm going to
g.
take the function. What does G of X equal?
Ax plus 2.
And I'm going to, see, that's what G of X equal to. I'm going to put that in place of X
Yeah.
in G of X. Does that make sense?
Yeah.
So I'm starting to write G of X, and I write A. But instead of writing X, what do I write?
Ax plus 2.
Exactly. Because that's me replacing it. You with me?
Mm-hmm.
Now, after the X, what do I have to put?
Plus 2.
Plus 2. Okay. Now, what can I do with this? Can I distribute this a little bit? Do something with it?
Yeah.
What's A times A?
A squared.
A squared X, right?
Mm-hmm.
And then what's A times 2?
2a.
Plus 2A, and then plus 2, yeah?
Mm-hmm.
All right. Now, this is GG of X. Now, what was the output of f negative 1 of 12?
6.
Now, what this means is if I go in and replace these x's, and there's only one of them, with a 6. Are you with me on that?
Mm-hmm.
If I'm going to take this 6 that's the output of this first thing, I'm going to put it on the input of GG of X. And so now it looks like this. A squared times 6 plus 2A plus 2. Now, what we've just done is we've taken the output 6 from this inverse 12 and put it into GGX. Now, when that happens, what does it equal?
62.
And see, now I can complete the whole thing. Now, help me clean this up. What's this going to be?
6a squared plus 2a plus 2.
But I'm going to, because it's a quadratic, clearly, right?
Mm-hmm.
So if I subtract 62 on both sides, what's it going to be?
It's going to be negative 60.
Yeah, exactly. Now, what would you do to solve this?
You can divide everything by 6. Well, no, you can't. No.
Yeah, it's close.
Yeah.
And that would be awesome, but you're right. This middle guy doesn't, right?
Yeah.
I can divide everything by 2, but then it's going to be 3, and this last number is going to be 30. It's still pretty big, and I would probably go to what you did before. It's probably not worth the trouble. I'm going to quickly jot. Now, actually, I'm not going to because I'm running out of room. But if I was taking the test, I would write down the quadratic formula, put it in there, but then I would use my calculator to find the answer. So do me a favor and tell me what answer you get. Menu A, and then plug in 6 for the A squared coefficient and 2, and then negative 60.
I got 3 and negative 10 thirds.
A equals 3, A equals negative 10 thirds. All right, now stop and think about what just happened. Does that make sense?
Yeah, I understand what you did, yeah.
I mean, instead of taking this inverse and putting it into G, which would be putting it into there, okay?
Mm-hmm.
And then taking that answer and then putting it back into there, what we did is we put the 12 in and we got this output. And see, then we only had to do this part. And we still have to take the output and put it into this. Anyway, that's a little confusing. All right, so let's take a look and see what the rubric says. So it's only 1 point, and it's a B. So, I mean, you need to give them, this is fine. Also, you'll notice I don't have the whole thing on here, it looks like. But they would have accepted interval notation too. All right? Any reasonable way to say this. And notice how they have f of x. We wrote y is greater than. I mean, technically, you notice how this is an f of x function and not a y equals function.
Mm-hmm.
Technically, if we were describing this, we should have wrote f of x is greater than or equal to 4 because it's not y equals. But I don't think you would have, I don't think that would cause you any problem or me any problem. And then here you'll notice in part B, they took the inverse, they switched the x's and y's, they get it by itself. Now, in this case, do you notice the method point is switching these and getting the y by itself? They would have accepted plus or minus for the method point. Okay?
Mm-hmm.
And then here, this is what they're looking for as the right answer. And you'll notice, now what they also did, what did we say? We said 2 plus, didn't we?
Yeah.
All right. They put that at the end, and it's no different. I mean, I noticed that they have a tendency to put the constant at the end instead of putting it in the front. But, I mean, what we wrote was equivalent to the same thing. But do notice that if it would have said plus or minus, or if it would have said minus, then you wouldn't have got this last point. And then in the part C, you can see where they took the quadratic and made it equal to that line. And then they're just showing us putting it together. And at the end of the day, we need to get this. Okay? And again, they notice how, so here we have our method point, putting, making them equal to each other. And the thing is, you do need to come up with something close to this. I mean, it doesn't have to be perfect, but yeah, this is what we're going for. This is going to get you the method point. And then solving the quadratic. And here's an excellent example where they're going to give you a point for solving it. If you just go and give the answer, you're probably not going to get that method point. So that's why I'm saying, even if you're using the calculator, make sure you at least write this down. And then the last point was 3, right? And you notice how they say only. Had we gone and said that the other answer was okay, where was it? Oh, wait a minute. We said 3 only. Oh, that's C. Yeah, we did that. Where's C? 3 only. Yeah?
Yeah.
If we would have left the negative 2/3, and again, notice how much work this problem is. Just make a mental note. When you're talking about these function ones and they have a domain, if you're solving anything, you've got to make sure that your answer fits within the domain. And then the D part, let's see what did it say. Oh, yeah, see, this is what they did. They took the 12, they put it in, and they got a 6. And then, well, actually, they did it right away. Well, that probably is smart. Okay, so do you notice how here they get the 6? They would have replaced this x with a 6 and this x with a 6 right away. It's not much different. You notice we did it and then put it in a minute later. But again, don't get me wrong, it's not going to be any different as far as the grading goes. And in this case, they have both answers. Okay, but notice 1, 2, 3, 4. All right, substitute the 12 into there. For example, say your inverse is screwed up. As long as you substitute the 12 into it and then evaluate it, you can still get this method point. And if you substitute, and if because your inverse was screwed up, well, then you clearly wouldn't have gotten a 6. But if you took your 6 and would have substituted it in to this, then you would have got another method point. So even if your inverse was screwed up, you could still get 4 out of these 5 points. All right, take a look here. And I did a video on transformations already, but what happens is that in the functions, they group together transformations and functions together. So I did throw one of these in here. Here, they're telling me that this is graphed, right? Now this is function notation. Basically what they want to know is tell them what happened here. What did we do to this function? What does a number in the front make happen?
It stretches it, right?
Exactly.
Or-
Now, is it a vertical or horizontal stretch?
Yeah, that's a vertical stretch. I
Yeah,
believe.
it's a vertical stretch. Okay? So if we're saying this, we're saying that it's a vertical stretch. And more than likely, they're looking for the words by a factor of 2.
Yeah.
Okay? Now, we took 1 away from the x's. What happened there?
It moved 1 unit to the right or along the x-axis.
Okay, so now, do you remember the whole this form?
Yeah, I remember that.
All right. So how does it work? What's
The
the top
one
number?
would be 1, right? That's the x value.
And that's going to the right. And so that left or right's the top. If you just wrote this, then this is one answer, and this is the other answer. If you don't write this, then you need to say that it's a vertical translation or shift along the x-axis by how much? By 1. What we
Yeah.
won't want to say is we don't want to say the words left or right.
Yeah.
Okay? Do you remember we talked about that before?
Yeah.
All right. Now, here they've given us this. Now, this has been reflected in the y-axis and then stretched by a scale factor of 1/3, but also in the x direction. So I want you to notice that part A, both of those are vertical transformations, and in part B, both of these are horizontal transformations. So they're kind of checking to see what we remember about both of those things. So, and it's actually kind of backwards because now they want us to actually do this to the equation. What would I have to do?
So wouldn't you multiply everything by 1/3 first, or no?
Well, not everything. Because if it was in the x direction, if it was vertical, if it was in the y direction, then I would have done this. I would have multiplied, because that would have been a vertical stretch, I would have multiplied everything by 1/3.
All right. Yeah.
Okay? But remember, because it's a horizontal one, it's inside. Okay? Now, here's the trick, though. With the horizontal one, it's not the same number. If I want to stretch it by a scale factor of 1/3, I don't put a 1/3 times the x's. What do?
You multiply by 3.
Yes. Do you remember that?
Yeah, I watched the video and I hated that. It's just it's that one little detail.
Okay. So this is going to cause this, if I multiply the x's by 3, it's going to cause it to be stretched by a scale factor of 1/3 horizontally or in the x direction. Okay? Now, what do we have to do to make it reflect in the y-axis? And again, back to this. If I was reflecting over the x-axis, what would that look like?
It will be a negative number. Yeah.
I would multiply the
Well,
whole thing by -1, right?
Yeah.
So what do you think is going to happen here?
You'll multiply a negative 1 only to the
To
x
the
values.
x's, just the x values. So what I'm going to do here is I'm going to multiply all the x values by -3. Does that make sense?
Yeah.
All right, so let's take a look at that. So I'm going to write this. y equals sine 2x minus 5x. So if I'm going to multiply the x's by negative 3, this stays the same. The 2's not going to change. And what's going to happen is I'm going to multiply the x by negative 3. Okay? Now, the x is already being multiplied by 2, but they're both having to happen. And then I'm now writing minus and the 5. And then I'm going to change this x to negative 3 times x. You with me on that?
Yeah.
All right. So now, keep in mind, this is all inside here. So what's 2 times negative 3?
-6.
So this is going to become sine negative 6x. Okay?
Mm-hmm.
And then, what's negative 5 times negative 3?
Positive 15x.
Positive 15x. So keep in mind, when you're talking vertical reflection, we multiply the whole thing by negative 1. And when we're talking about a vertical stretch, we multiply the whole thing by whatever the number is we're stretching it by. But when we're doing a horizontal stretch, we're going to multiply the x's by the reciprocal of whatever number they want it to be. And if I want to reflect over the y-axis, then I'm multiplying just the x's by negative 1. Right? So let's see what the rubric says. Okay, so once again, if you just write this, it's the simplest and easiest way to say that it shifted to the right and didn't move up or down. But you'll notice you can still get credit for saying that it moves 1 in the x direction or parallel or along or against the x-axis or horizontally. I mean, but again, I really recommend that everybody try to learn this notation in describing a translation because this says all that. And then we talked about the stretch and we got this is fine. Okay, so they talked about it being a stretch. I'm surprised they don't have to have it be a factor. Oh, wait, they do. Oh, notice how that was, they do said this. It's got to be by a factor of 2. Okay, so the word stretch, and then it's got to be in the y direction by a factor of 2, and the y parallel to against, along. Notice here, if it says upwards, it's worth nothing. Okay? They don't want to use the words up, down, left, or right. Here, also notice in this first one, if we say it moves to the right only, okay, now, mine, it's like if you had something else and then you said it moved to the right, they would still give you credit for this. But if you just wrote that it's a translation of 1 to the right, it says specifically not to give you credit for it. All right, and then you'll notice we ended up doing this. Quite honestly, I'm not really sure how they got this.
Oh.
But
Yeah.
this is what we ended up doing. This kind of makes sense to me. And again, notice in this problem, what happens is, see how they've got these brackets? They've got this bracket here and this bracket here, and it's worth 2 points. If you had this, that would be worth 1 point. If you had this, that would be worth the other point. So even if you messed up one of these things, you could still get one of the 2 points. Anyway, that's what's going on with that one.
Do you have to put brackets or no?
No, what I'm saying is this is what the rubric looks like. So those brackets are telling the person that's grading it that if they see this and this is correct, they can give you 1 point. And if they see this, then they can give you the other point. But no, it's not about the brackets. It's telling the grader that it's worth 2 points, but you know, it's telling them specifically what each point is worth.
Oh, okay.
All right, take a look at this one. This function is defined 2x squared plus 3. And again, you'll notice they have had a domain. They do this, they're going to do this quite frequently. They're going to give the domain for the functions. Quite honestly, mathematically, technically, you should always give a domain for your function. Uh, Most times when the function's domain is all real numbers, people just don't. But you'll notice that in most of these problems, these function problems, there's going to be a domain. And part of it is going to be because when we do inverses, we really have to know that. But anyway, it says to do this. Find and simplify the expression this. Okay? Now again, this is a composite function like you were saying before, and there is no input in this case. So take a minute and see if you can't do that. This is similar to the one where we put the G in the G, where in this case we're putting the F in the F. So what are you thinking? How you doing?
I finished.
Tell me what you got.
I got ax exponent 4 plus 24x squared plus 21.
All right, that's perfect. So all we're doing is basically taking 2x squared plus 3 and putting it in place of x. And so you squared this, then multiplied the whole thing by 2, and then you added 3, right?
Yep.
All right, now what does part B say to do?
It wants you to make it equal to 34x squared plus 19.
Exactly. Now notice they're telling this and to make it equal to this. Well, this is this, and so I'm going to put that there and make it equal to 34x squared plus 19. And so now I'm going to get rid of this because I don't want to make that look bad. Okay, so now what?
You want to get everything on one side.
Exactly. So what are we going to do?
Subtract 34x squared from 24 and subtract 21
So what's
from
24x squared minus 34x squared?
negative 10x squared.
Awesome. And then what's 21 minus 19?
Negative 3. Wait, no, negative 2. Oh, this is why I don't do mental math.
21 minus 19.
Yes, negative 2.
Not negative 2. 21
Oh, no,
is
no,
bigger
it's,
than
yeah,
19.
2. Yeah.
2, right?
Yeah.
All right, but now, like you say, we got it on one side, we'll make it equal to 0, right?
Yeah.
Okay, so how do we solve this?
We use that H thing.
Yeah, I like that. So no. So here's what I'm going to write it down. We're going to say, see this middle term? We're going to say that h is equal to x squared. Consequently, h squared is equal to what?
X 4.
To the 4. And see, now what we're going to do is we're going to rewrite this equation with h's. So what's it going to be?
8h squared minus 10h plus 2.
And once again, you could use a quadratic formula. And we could divide all this by 2, right?
Yeah.
If I divide it all by 2, what do I get?
You get 4h squared minus 5h plus 1.
Now again, you can use the quadratic formula, or we could factor it. What's 4 times 1?
4.
And then negative 5 at the bottom. And I'm going to write this here and write this here. What are two numbers that multiply to 4 and then add to get to negative 5?
Negative 4 and negative 1.
These are the opposites of our answers. Our answers are h is equal to 1 and h is equal to 1/4. Are we done?
No.
Why not?
Because you use the h and you substitute it with the x's, so now you have to
Put
do
it
1/4.
back. Exactly.
Yeah.
H equals what?
X squared.
So now I gotta go. Now that I've done my work, I've got to replace the h with what it's equal to. So now what do I do?
You will square it to each side.
Square root, square root. So this is going to become an x, and what's this going to become?
Plus or negative 1.
Plus or minus 1. And what's this going to become?
Plus or minus 1/4.
All right, are we done?
No, I don't think so. Yeah, because, that domain.
What do the x's have to be?
That to be greater than 0.
So what answers can I not use?
You can't use the negatives.
And can you see how this is the end of the problem and you just want to get on to the next one? And it'd be so easy just to leave it this way. Because if this domain, in fact, in this problem, we're not finding the inverse. It's not necessary to do this. It is truly to see if you notice this. All right, so just keep in mind with these function questions, when you're solving, always look at the domain and make sure that your answers fit within the domain. You're literally telling you what x is allowed to be. And if you say x is something else, well, it can't be that. All right, so let's take a look. Because this was worth 2 points. All right, and that wasn't too bad, was it? You have to be a little careful. And then this is worth 4 points. And honestly, if you know how to do this, this is actually, I think, almost even easier. It's a little bit more work, but this is actually easier, I think, than part A, or it's certainly not any harder, as long as you know how to do it. Some people see this to the 4th power, and then they can't remember what you remembered. All right, so here you'll notice they did this, they expanded it, they got that, they just plugged it in. So basically what they're saying is, I'm going to give you a method point. I'm going to give you a method point for taking this and putting it in that. And even if you screw it up and you don't get this, you can still get the method point. And then if you do get it right, then you get the both points. And then here you'll notice that, again, a method point for just literally getting everything on, make them equal each other, and then getting everything to one side. And then actually having what you're supposed to have is going to give you another point. And see now, an attempt to solve the 3-term quadratic. And again, you'll notice how they say specifically, either factoring or formula or complete the square or factor theorem. But the thing is, in order to get this point, you have to show some method for solving that thing. And I did I did it by hand, but you could easily just write the quadratic formula and use your calculator. But it's really important because, like I said, there's no sense in not getting this point just because you didn't write down the quadratic formula. And again, you'll notice that the ending here, they need to see that you got the x squared and this, but then you end up with these two answers. And again, only the positive ones. Now in this case, let's see. All right, so you notice how here, they're perfectly okay with this part being plus or minus. Okay? Oh no, let's see. All right, so in this case, they would have given you credit for plus or minus. Now also notice here that there's if they don't see something, you're not getting a method point. If they don't see some kind of method in the way you solve this, they're telling that the grader specifically don't give them that point. Now you can still get the right answer point. Oh, you know what? I take it back. I'm thinking now that I'm reading this, if they don't see the method, they're not even going to give you this point. Okay?
Yeah.
So, I mean, that's really important. All right, that's not too bad though. And again, I want you to notice there's this kind of pattern in these function questions, and I just pulled them. Do you notice how they give you, like a lot of times they give you two functions, they give you two of them. And you'll notice that one of them is going to be some kind of composite. And then there's going to be some kind of inverse. Those are the two big pieces with the functions, is doing a composite function and then finding the inverse of something. So basically, what does this mean?
They want G to go to F, and then you plug in the 3 to the X values.
No. That would be this. If this said this...
Oh, wait, no. You plug in G to F, and then you go to 3. My bad.
Exactly. All right, so now what are we doing? We're taking this, and where are we putting it?
E to the F to the X.
Right?
Yeah. Mm-hmm.
Okay, so what's that look like?
That is 1 over 2x plus 1 squared minus 1.
So that whole thing is squared, right?
Mm-hmm.
And then minus 1. Okay, now, what do they want me to do to that?
They want you to equal it to 3.
So, right, equal 3. And then notice what they're saying.
Solve.
Okay. So, how are we going to do this?
I just thought about the chain rule for a sec. I don't know about that.
Well, so in this case, think about it. We're trying to get x by itself, right?
Yeah.
So, first thing I'd probably do is add 1 to both sides.
Mm-hmm.
Now, the other thing is, if I have 1 over 2 squared, what's it equal to?
1/4.
Which is the same thing as 1 squared over 2 squared. Isn't that true?
Mm-hmm.
Keep in mind, when you're squaring a fraction, you can just, so let's do it, we can do the whole thing or we can separate it. Right? Because 1/2 times 1/2 is 1/4, but 1 squared is 1 and 2 squared is 4. So what if I did 1 squared? What would that be?
If you did
1, right?
Uh-huh.
And then let's go ahead and let's just make this 2x squared. Or 2x plus 1 squared. Okay? Are you with me on that? Now what's it equal?
4.
Alright, now what can we do?
You can expand 2x plus 1.
Yeah, you could do that. Or what else could we do? Can I cross multiply?
Yeah, you can do that
Can
too.
I get this out of the denominator?
Yeah.
Before I do that, that's what I'm thinking I want to do. Do you think that makes sense? So what happens when I cross multiply? What do I get?
You'll get 8x.
Well, I'm just going to, because remember this is squared, right?
Yeah.
So it's going to be 4 times 2x plus 1 squared equal what?
1.
Now what are we going to do?
You expand the 2x plus 1
All right,
squared.
let's do that. What do we get?
You get 4x squared plus 4x plus 1.
And then that whole thing gets multiplied by
4.
So this is going to be 16x squared plus 16x plus 4 equal 1. Yeah?
Mm-hmm.
And then what's going to happen?
You'll subtract to 1 by both sides.
Yeah?
Mm-hmm.
Now what?
You have to solve for x.
Yeah, try it. Tell me what you get when you put it in the calculator.
I got negative 1/4 and negative 3/4.
So, x is equal to negative 1/4 and x is equal to negative 3/4. Right?
Mm-hmm.
Now, notice how we did this composite. Look at our domains. What happens is we're going to have to use the more restrictive domain. So tell me, is negative 1/4 less than negative 1/2?
Yeah. Wait, no, it's not.
It's not, right?
Yeah.
Think about your number line, right?
Mm-hmm.
0, 1, negative 1. There's going to be negative 1/4, and then there's going to be negative 1/2. Negative 1/4 is going to be here, and negative 1/2 is going to be here, right? 1/4 is going to be bigger. I can't use it. Now, negative 3/4, is that less than negative 1/2?
Yeah.
All right. So what happens when you do a composite function, use the more restrictive domain. Because we have both of them. Does that make sense?
Yeah.
All right. Now tell me about B.
It wants you to find the inverse of f of g.
And this is...
Or not f of g, but yeah.
And I'm going to tell you, a whole lot of times with these inverses, well, well, I'm going to write it down here. What do we got? Basically, let's say y equals 1 over 2x plus 1 all squared minus 1. Okay, that's f of g, right?
Mm-hmm.
So if we're going to do the inverse, oops, forgot my squared. It's going to look something like that, right?
Mm-hmm.
All right, so what do you want to do with this?
Add 1 to one side.
Yeah, I'm thinking the same thing, so let's go ahead and do that. Add 1. And then I'm probably going to do the same thing we did before by making this a 1 and this 2y plus 1 squared. You with me on that?
Mm-hmm.
Okay, now, the problem with this is the y is in the denominator. Okay? So I need to get the y by itself, but right now it's stuck in the denominator. So what can I do?
Can multiply by the reciprocal.
Well, yes, exactly. So I'm going to multiply both sides by 2y plus 1 squared. And then 2y plus 1 squared. Yes?
Mm-hmm.
Now these are going to cancel out. And so it leaves me with this. 2y plus 1 squared times x plus 1. I'm going to write it again because it's kind of messed up. And it's going to equal 1. All right, now what are we going to do? Keep in mind, we're trying to get the y by itself.
Mm. You can look for a factor of y, I think.
Well, notice how these two things are being multiplied together?
Uh-huh.
And notice how this thing doesn't have any y's with it at all?
Mm-hmm.
What if I divide by x plus 1? Now this cancels out, right?
Mm-hmm.
So now what are we going to do?
After wait.
See, in this case, we're probably going to have to square root both sides.
Yeah.
Because notice, what happens if I square this? What am I going to end up with?
You'll be left off with 2y plus 1.
Well, but if I square it, because see how this is squared? If I square that binomial, I'm going to end up with 4y squared plus 4y, and then you notice how I've got a 4y squared and then a 4y? I'm never going to get the y by itself. So if I square root this, what's this going to become?
Yeah.
And notice how there's only one y? I've increased my chances of getting it by itself. Now, that means all of this is square rooted. And like I said, if I square root a fraction, what's the square? I can do them separately. What's the square root of 1?
1.
Right? And then this is actually going to be the square root of x plus 1, yeah? But then we're going to put plus or minus. Yeah?
Mm-hmm.
All right, now what are we going to do?
You're gonna subtract 1.
Yeah, subtract 1 and then divide by 2, right?
Mm-hmm.
So y is going to equal, we're going to subtract 1 and divide by 2, yeah?
Mm-hmm.
Plus or minus 1 square root x plus 1. And I got to tell you, as far as these finding inverse ones, that's a pretty rough one.
Yeah, those getting y and x by itself, I feel like that's the hardest part.
Yeah, that's a pretty rough one. And then, let's see here. All right, so notice our FG was a quadratic, right?
Mm-hmm.
And notice we're doing the x's are less than this, right?
Mm-hmm.
So when we square root both sides, should it be a plus or a minus?
It should be a minus.
Yeah. So let's fix that. Okay, let's take a look and see. So here, you see we're plugging in setting it equal to 3, and then they still get negative 3/4. Is that what we got? Yeah, negative 3/4. All right. And then for this part, and see here, the method, they're allowing the plus or minus, but do you notice at the end of the day, it has to be a minus?
Yeah.
But I got to tell you, that's a rough one. Most of the time, when I'm seeing when you have to find inverses, it's either a quadratic, a linear, or like this, where it's a rational. That was a pretty complicated one. It's 4 o'clock. Did you have any questions about any of the stuff we were doing the other day?
I'm still working on the sheet. I don't see I don't have any trouble, but I was wondering if we can go over the test, the previous one,
Which test is that?
the most recent one that we took.
Let me see. Oh, you mean the one on Monday?
Yeah, it was the most recent one. The recent one. Yeah, it was Monday, right? Yeah.
All right. Let me see here. Oh, okay. No, unfortunately, I can't because there are probably about 4 people that are taking it tomorrow afternoon.
Okay.
And so if I post this video, then they're going to see the test.
Yeah, I got you.
But after tomorrow afternoon, or like I said, if you want to, well, actually, if you want to stay tomorrow, because people are taking a test, well, let's see, I can't really talk to you about
Yeah,
the
you
test
can't do
while they're taking it.
that.
But on Monday, I'll be staying, and if you want to talk about it on Monday, we can do that.
Yeah, I want to go through like the questions that like I missed and like some of my confusions.
Yeah, and I don't have the, and what's more, I don't have your test here at home with me. They're at school, and so it'd be
Hmm.
better if I had it so we can look at it and we can see what you messed up on. What did you have trouble with? What do you remember having trouble with?
I have no
The
clue. I just feel like that I'm not
the first
grasping the
question
information.
was um, the independent, and what were the 2 things, independent or not?
Yeah,
Do you know how to do that?
I think I do. I just forgot. Yeah, I don't know. Like I understand it, but I just have a lot of gaps. You know.
Yeah. Yeah, we definitely can do it. We just can't do it now. Because, like I said, number one, I don't have your test. And number two, people are taking it again tomorrow.
Yeah.
But we can definitely do it on Monday.
Yeah.
Or after. Well, like I said, I don't know how many people are going to be here tomorrow. And I don't know who is going to be taking the test. But we'll definitely make sure that we do that. I just can't do it now.
Yeah.
What about these probability distributions? Are you okay with those?
Yeah, I feel pretty good. I understand that. I understand that.
Tell me about this. Hang on. Did you finish that paper?
No, I'm still working on it, but I'm almost done.
So tell me what you're doing 8 and 9. What are you doing with those?
So for number 8, the first thing I did was write down the chances, or not the chances, but I did a chart for like
Okay.
the dice.
And did you add them up, or what did you do for number 8? So you wrote 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6,
Yeah.
and then now what did you put in the middle?
I just put just the sums.
All right, that's good. All right, and then you took these numbers, and then you could build a table, right? What's the smallest possible number?
You can get 2.
What's
Smallest
the
one.
biggest possible number?
12.
Yeah, exactly. And what's the probability of getting a 2?
2 out of 36.
2 out of 36?
Yeah.
How many ways can you get a 2?
Yeah. Oh, no. 1 out of 36.
Yeah. How many ways can you get a 12?
1 out of 36.
Exactly. Right?
Mm-hmm.
So you're counting these up. This would be 3. This would be 3. How many ways to get a 3?
1, I believe. No, because you can get 1, 2. Yeah,
1, 2,
2.
and 2, 1, right?
Yeah,
So that's going to be 2 out of 36, right?
yeah.
And then how do you find the expected value?
You use the formula.
Right? What's the formula?
It's the sum of the x value squared times p.
That's the
minus-
variance. How do you find the expected value?
Oh no! You multiply the actual number to the not the actual number, the x to the
Probability.
lowercase.
And
Yeah.
add those things up, right?
Mm-hmm.
And then how do you find the variance?
You use the formula.
Use the square of those numbers times the probabilities, add them up, and then take away what?
The sum of
The absolute value squared.
Yeah.
Right?
Mm-hmm.
So what's different about number 9? You're still making this chart. What's different about it?
Has to do with the absolute difference.
Yes. What's that mean?
You're basically subtracting.
We're going to be subtracting, but it's going to be the absolute value. So if I go 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. What's 1 minus 1?
0.
What's 2 minus 1?
1.
3 minus 1?
2.
3, 4, 5, right?
Mm-hmm.
What's 1 minus 2?
-1.
But we're going to write 1 because it's going to be the absolute value. What's 2 minus 2?
0.
What's 3 minus 2?
1.
What's 4 minus 2?
2.
What's 1 minus 3?
-2.
But we're going to write,
2.
and then this is going to be 2 minus 3, which is -1, but it's going to be 1. And see, do you notice how this pattern is going to exist? It's going to go 1, 2, 3, and then 4. Whoops, I lost 1, didn't I?
Yeah.
1. Hang on, screwed up. Because the pattern didn't work, I knew I messed up. This is going to be a 1, and then a 2, and a 3. Yeah?
Mm-hmm.
All right, now, you're going to do the exact same thing you did over here, only we need the whole table to figure out what's the smallest number going to be.
0.
But we don't know how many times it's happened, though it looks like it's going to happen 1, 2, 3, 4, 5, 6. Don't you think that's what's going to be?
Yeah.
All right, so that would be 6 out of 36, or 1/6, right?
Yeah.
And you notice the ones, they happen here, they happen here. They're probably going to be scattered. You have to make sure you catch them all, right?
Right.
And then what about number 10? What are we doing with number 10? Six black pens, 4 red pens. How many are we taking out?
You're taking out 3 pens.
All right, so first let's start with that. What's the smallest number of red pens I can take out?
0.
And then,
1.
and then,
2.
and then.
3.
All right, now, I need to know the probabilities. These are my, we'll say they're x's. I need the probability of it being a 0. So think about this. We're choosing pens, right?
Yeah.
So I've got how many black pens?
You have 6 black pens.
And how many red?
4.
Now, if I have 0 red pens, what did I do?
You did 3, choose 0.
How many red pens are there?
Oh no, 4, choose 0.
All right, but what about the blue ones or black ones?
That would be 6, choose 3.
and then times 4, choose 0, right?
Mm-hmm.
That gives me 3 pens that are black, yes?
Yep.
But I need the probability. So what do I divide by?
You'll divide that by
How many pens do I have altogether, not caring what color they are?
10.
And how many am I choosing?
3. That'll be 10 choose 3.
This is telling me how many ways I can choose 3 things out of 10. Now, this is going to give me the probability when I'm picking 0 red ones. Yes?
Mm-hmm. Yeah.
Now, so this is the probability that x equals 0. How would I figure out the probability that x equals 1? Now, keep in mind, what that means is that out of the 3 pens, one of them is red.
Yeah.
So how am I going to do it?
You'll do 4 choose 1
4 choose 1 times what?
6 choose 2
6 choose 2. And once again, I'm going to divide by.
10 choose 3.
And see, the reason I'm saying that you want to write this out first is because if you put this in your calculator, do you see how it's going to be really easy to change these couple numbers and then figure out the next probability?
Mm-hmm.
What is the probability that x equals 2 going to be?
That'll be 4 choose. Oh no. Yeah. 4 choose 2
4 choose 2 and 6 choose what?
times 6 choose 1.
And again, this still be this. And then there's only one more to do, and that's going to be the probability that x equals 3. And what's that going to be?
That will be 6 choose 0 times 4 choose 3.
And see, then we have our probabilities. Like I said, it seems like a lot, but if you type this in your calculator and then put the probability and then change the numbers and then put the probability and then change the numbers and then put your probability and then change the numbers and put the probability, you really can do these pretty quickly.
Yeah, but I feel good about these. It doesn't seem like too bad.
No, it isn't too bad. Now, what's going to happen is that we're going to talk tomorrow about binomial distributions, and I know it sounds crazy. It actually isn't bad either. It's a specific situation, and again, it really isn't bad. The trick is you got to recognize when we have this situation. But there's a formula, and it's on the formula sheet. There's a formula that we're going to use, and it's on the sheet, and it really isn't that hard. Well, do you remember the binomial distributions where we did
Yeah.
the binomial expansions? We did
I
the
remember.
combination, and then 2 things. It's going to be
Yeah.
similar to that. But what's going to happen is that we're going to talk about that tomorrow. What day's tomorrow?
Friday.
Friday. And then on Tuesday, we're going to talk about geometric distributions, which, quite honestly, is the easiest one yet, if you can recognize what the situation is. And then, that won't even take a whole class period. We'll be able to do that one probably in half the class period, and then we'll do some practice. But what's going to happen is that we're going to be finding some more probabilities. That's what most of these two chapters are about.
Yeah. This math really does play with your brain. You really gotta think.
Yep, it does. It's a lot, and it comes fast.
Yeah.
We're getting towards the end, though.
Yeah, thankfully.
I know.
I was counting the months. Like, that exam is coming soon.
It is. Well, think about it. I forget when's spring break.
It's in April 9th, I think. Yeah, April 9th.
And see, our goal is to be done with this whole book before spring break. And then what's going to happen is that When we come back from a spring break, we're only going to have like a week and a half, and then we're just going to be practicing. I mean, if we can get done before spring break, when we're going to start reviewing, the sooner we start reviewing, the better it's going to be.
Yeah.
Because I tell you, the people that get the best experience on the exam, they tell me the best preparation is actually working exam questions. Getting used to the kind of exam questions that they do and how they word them and what to look for. And my hope is that we're going to do more of that than I've ever been able to do before. And I think that when you guys go into this pure math test, like I said, I think that you're going to walk out and, well, don't get me wrong, it's going to be a hard test. I mean, it's going to be a hard test, okay? But the thing is, I honestly believe that you guys are going to be better prepared than any class that I've had before.
Yeah. These tutoring videos, they really do help.
What's that?
Like these videos, like they help, like retain the information still.
Well, and like I said, the nice thing about it, like, I mean, I wish more people would come because you're really being smart by doing this, like looking at stuff that we haven't done for a while and then just getting it in your brain again. When we go back to review, a lot of it is going to be much more familiar to you than when people that haven't looked at any of this at all, and then they're going to have to go back and relearn everything.
Yeah.
And see, even like a lot of this stuff, you've been able to retain, and it's been a long time since we've done some of this stuff.
Yeah. I remember doing this in October or September.
Exactly, right?
Yeah.
So, but that's why I'm videoing them too, because I'm hoping that people will still watch them, and it'll help keep things fresh in their brain.
Yeah. I'm pretty sure they do watch it. They just like have, practice or clubs or stuff.
Yeah, I know. Well, the people that are putting these on, they're kind of concerned because kids aren't showing up. And it's like, listen, they're watching the videos, like they're doing it on their time. They got things to do after school a lot of times.
Yeah.
So anyway. All right. Well, you got any other questions for me?
Yeah, so Monday we can go over the test?
Yeah, I don't see why not.
All right. Yeah, that sounds good.
Okay, so like I said, we'll just make up. I think I've got some kids coming to do something on Monday anyway. But like I said, let's just see if we can't plan on, taking some time and going over your test on then.
All right. Yeah.
All right. I'm not sure, but it's possible if enough people take it, or if we get it all squared away, I might go over it with everybody in class on Tuesday.
Oh, that's even better.
Yeah. Well, like I said, that's kind of my plan, but more people than I have ever missed this test.
Yeah.
And so I'm hoping if we can get enough people to take it, then I can go over it on Tuesday. But like I said, I'll know on Friday. And if we're not going to do it in class on Tuesday, then like I said, we'll definitely do it on Monday after class. But that's my kind of hope, is that we're going to do it on Tuesday.
Yeah.
All right. Well, I'm going to let you go. Have an awesome day. Thanks for coming.
Yeah, thank you, Mr. Cross. Have a good day.
You too.